In the last video, we met exponential notation. We found that powers simply indicate repeated multiplication, so that 3 multiplied by itself 5 times can be written as 3 to the power of 5. We also found out that when we multiply numbers together with exponents, we simply add the exponents. For example, 7 to the power of 2 times 7 to the power of 3 equals 7 to the power of 2 plus 3, which is 7 to the power of 5. And finally, we found that this rule only works when we have numbers with the same number base. So for example, we can work out 2 squared times 2 to the power of 5 equals 2 to the power of 7, but 2 squared times 3 squared does not equal either 2 to the power of 4 or 3 to the power of 4. We'll now look at the question of division. You might think that if repeated multiplication means adding exponents, then division means subtracting exponents. And you'd be right. Let's write out a nice simple example. 3 to the power of 5, for example, can be written as 3 times 3 times 3 times 3 times 3. And if we divide that by 3 squared, we're going to divide that by 3 times 3. This cancels with this to give 1, this cancels with this to give 1, and we are left with 3 to the power of 1, 2, 3, or 3 cubed. And we can rewrite that as 3 to the power of 5 divided by 3 squared equals 3 to the power of 5 minus 2, which gives us the answer above, 3 cubed. We'll do one more example. Pi to the power of 9 divided by pi to the power of 4 will give me pi to the power of 9 minus 4, which is going to be pi to the power of 5. If we carry on doing this, we'll see a nice simple repeated pattern. As you can see here, when we have 2 multiplied by itself 4 times, we get 2 to the power of 4. When we divide by 2, we get 2 times 2 times 2, and this here, this 1, is 2 divided by 2, and that gives me 2 cubed. Obviously, if we divide by 2 again, we get 2 times 2. Here we have our 2 divided by 2, giving 2 squared, and finally we have 2 multiplied by 1, which gives us 2 to the power of 1. This might seem a little strange to some people. Generally speaking, we don't write out a single number as that number to the power of 1 because it's a waste of time. But in this case it does make sense because you can see that it follows the pattern 2 to the power of 4, 3, 2, 1. I'll now ask what seems like a very odd question. What is 2 to the power of 0? I'll let you look at the list for a moment and see whether you can come up with an answer. You might think that 2 to the power of 0 has absolutely no meaning whatsoever. After all, when we've got, say, 4 2's, we write a 4 here, 3 2's, we write a 3, 2 2's, we write a 2, 1 2, we write a 1. Here, clearly we have no 2's, so obviously there is no number there. Let's divide this equation here by 2. this looks like a very strange result. What we're saying is that 2 to the power of 0 equals 1. We're just saying that 2 to the power of 0, or indeed any number to the power of 0, is simply that number divided by itself. If this seems a little incomprehensible, you can possibly find some solace in thinking of these not as some magical incantation, it's mathematics. These are just instructions, and these instructions tell you what to do. They tell you how to understand these black marks on a page. And this series of black marks tells you multiply the number together 4 times, multiply the number 3 times, 2 times, 1 time. And this instruction here is doing nothing more than telling you take a number and divide it by itself to give you 1. Of course, we don't have to stop at 2 to the power of 0. We can divide by 2 again. So you can see the pattern. We've gone from 4, 3, 2, 1, 0. We've now extended our notation down into negative figures, and again we can understand this as being nothing more than an instruction that tells us when you see a power to the minus 1, it means 1 divided by a particular number. And the minus 1 in this case indicates that you divide by that number once. And if we carry on the pattern, we see that 1 over 2 squared is going to give us 2 to the power of minus 2. 1 over 2 cubed is going to give us 2 to the power of minus 3. And very obviously 1 over 2 to the power of 4 equals 2 to the minus 4. So if we just pause for a moment and think about what we've got so far. We started off with a simple definition of exponential notation, meaning repeated multiplication. But by simply following through a chain of logic, by dividing by a particular number every time, we've discovered that the apparently meaningless number to the power of 0 actually equals 1, and this applies to any number other than 0. 0 to the power of 0 is a very contentious question. We're not even going to look at that. And we can extend that into negative figures. And again, for negative figures, if the base is 0, 1 over 0 is going to be, at the very best, infinity. So these rules only really apply as long as the number base isn't 0. But you can see that with a number other than 0, we can extend this notation to include negative numbers, which we've defined as being 1 divided by that many numbers. So 1 over 2 cubed becomes 2 to the power of minus 3, and 1 over 2 to the power of 4 is 2 to the power of minus 4. In the next video, we're going to be looking at what these numbers actually look like. See you in the next video.